Hello, my name is Tae-Soo Chung. I'm the professor of Industrial Management Engineering at Korea University, and I'm one of the instructors for this course. So for me, I will deliver some basic algorithm and concepts of the unsupervised learning and the reinforced learning over the 4 weeks. So for this week and next week, I will talk about some basic concepts and the algorithm in the unsupervised learning. And after then, I will spend 2 weeks to talk about the reinforced learning. So in today's sessions, I'd like to talk about some basic idea about the unsupervised learning. So we're going to briefly review the definition of the unsupervised learning. After then, one of the unsupervised learning algorithm is the clustering problems. So I'd like to talk about some clustering what the clustering problem is, and we're going to take a look at one of the algorithm in clustering problems, which is the hierarchical clustering. All right, so before introducing the concept of the clustering problem, I'd like to talk about what is the main differences between the supervised learning and unsupervised learning. And, probably you already learned what the supervised learning is. Basically, supervised learning examines the relationship between the input variables and the output variables. So you have some kind of the desired answer, and you'd like to identify some kind of relationship between the input and outputs. And based on the problem, based on the criteria to minimize the normally mean square errors. So here's the example of the supervised learning. This is the regression example. So there is some relationship. There is some two variable x and y, and you have the scatter plot, and you'd like to identify the relationship between x and y, and you'd like to identify some model the model that will represent the relationship between x and y. So in these cases, we identify some linear function. It's like this. So you can express the relationship between x and y by using these functions. So y is equal to 1.108 times x minus 105, and so on. On the other hand, the unsupervised learning, in the case of the unsupervised learning, there is no information on y. In other words, you try to learn information without any label information. Label information is the value of y, which is the desired outcome. So basically, in the supervised learning, we are just interested in finding something interesting in the input variables. So basically, unsupervised learning is used for the exploratory data analysis. So for example, the clustering, the finding of subgroups, or data visualizations. And over the 2 weeks, we will talk about some algorithm in the unsupervised learning. So today, our main topic is the clustering. So what is the clustering problems? So what is the clustering? Clustering is to organize the unlabeled data into some groups called the clusters. So that is the definition of the cluster. Cluster is this set of the data point which are similar to each other and dissimilar between other clusters. So we try to group the point into the sum number of the so-called cluster so that the data point within the cluster are close or similar to each other. At the same time, the data point data point of the different clusters are dissimilar. So basically, by using the clustering problem, by solving the clustering problem, we try to explore the inherent and the natural structure of the data point. So in that cases, if you take a look at the graph, so there is a graph of the graph consisting of the x1 and x2. So we have the two input variable, x1 and x2, And if you see the scatter plot, there is no indication about the output. So basically this data is unlabeled data. There is no Y. And basically by using some clustering algorithm, you try to identify some natural groups, right? So for example, this is kind of example. So this part, and this part, and this part. So try to, by taking a look at the data only, we try to identify the 4 different clusters. And in a cluster algorithm, identify them as some kind of natural group for each data point. Okay, so before moving on, I'd like to briefly take a look at some historical application of the clustering. During the 1850s in London, there was a cholera outbreak, and one of the London physicians called John Snow actually plot the location of the death on the map. So what he found out was the death cases were clustered around certain intersections. And it turns out that, there was some contaminated wells. So because of that, it caused some the cholera outbreak. So that is the kind of example, historical example of the clustering. All right, so we are currently talking about what the clustering problem is. So we'd like to identify some natural groups within the data point, given the data points. So what do we need to consider in the clustering problems? Basically, in the clustering problem, we'd like to identify some the set of the clusters such that the data point in the clusters are similar or close to each other. At the same time, the data point in the different clusters are, dissimilar. So we need to have some measure to say, which data points are close to each other, or which clusters are close or dissimilar to each other. So we need some measure to calculate so-called proximity or distance, so that we can say 2 points are close to each other, or 2 points are not close to each other. After then, we need some measure, quality measure, to evaluate the outcome of the clustering problem. Right? So we have the set of the clusters for the given data. And depending on the algorithm, probably you may have another set of the clusters. So you may have some measure to evaluate which cluster is better than the other clusters. So we need to have some goodness or quality measure. Then finally, we need some algorithm to compute the clustering. So these are the factors we need to consider for clustering problem. So we'd like to take a look at one by one. Right. So we first take a look at the proximity or distance measure. So as already mentioned that we need to consider 2 types of measure in this case. One is the distance measurement between 2 data points. And we also need to consider the distance measure between clusters. So there are many measures associated with the distance measurement between 2 data points, including Euclidean distance, Manhattan distance, cosine similarity. And in case of the measurement of the distance between 2 clusters include the average linkage, single linkage, complete linkage, and centroid linkage. And the choice of this measure or metric depends on the data and the analysis purpose. Right, so here is the example of the distance measure or distance metric between 2 data points. Probably you may be familiar with the Euclidean distance, right? So the data point, you just have the straight line, and you need to measure the distance, the length of the straight line connecting 2 data points. Right, so So Manhattan distance. Manhattan distance is the distance between 2 points in the grid. In a grid. So it's nothing but the sum of the horizontal and the vertical component. So horizontal component and vertical component. So the one of the measure to calculate the distance between the two data points is the cosine distance or cosine similarity. So this cosine similarity is a measurement of the similarity between two data points that measure the cosine of the angle between them. So it is a judgment of the orientations and not the magnitude. So for example, if let's think about the two vectors and the angle is near to 0, so the similarity score is equal to 1, right? And on the other hand, if you take a look at the these cases, so angle is near the 180 degrees, the score is -1. So you can see how it works. It just calculate the cosine of the angle of the two data point. Okay, so we now talk about the distance measurement between clusters, right? So one of the measurement is the average linkage. That calculate the mean distance. In other words, average linkage calculate the average of the distances between all the data point on two clusters. So you need to calculate the pairwise distance between where each point belong to some designated clusters. So you calculate the distance and then average them out. So that is the one of the measure called average linkage. The single linkage calculate the minimum distance between two clusters. So you identify the two nearest neighborhood which belong to each clusters, and you just calculate the distance to nearest neighborhood in two clusters. Okay, so you can consider the opposite cases. You can calculate the maximum distance between two clusters. So that is called the complete linkage. So the complete linkage, it calculates the distance between the farthest point in two clusters. Then finally, the central linkage is to calculate the distance between the centroid, which is kind of the center of the clusters. You can think about as the center of the gravity. And you just calculate the distance between the centroid in those two clusters. All right. So we also need to think about how we're going to evaluate the clustering. Normally, the evaluation of the unsupervised learning, including the clustering, is very difficult. So when you think about the result, the evaluation of the result can be somehow subjective compared to the unsupervised learning. In case of the supervised learning, you have some deserved answer. But unsupervised learning, we don't have those answers. So that's why it is somehow difficult to evaluate the result. Of course, the clustering also difficult to evaluate. And indeed, there is no good model to compare. So for example, you can make an inspection. So by taking a look at the outcome, and then you can say, one clustering is better than the other one. That is one possibility. Or you can think about if it is possible, you can make a comparison between the clusters. You can make the comparison of the cluster with the true partition of the data, if true partition of the data is available. And that is called external evaluations. So external evaluation is to compare the result with the labeled data. But normally, it is external evaluation is not possible, right? If so, probably you may use the unsupervised learning, right? And you also think about some, evaluating the result to evaluate the quality of the clusters without reference to the external informations. basically, if you remind what we've discussed before, in the clustering, we try to identify the compact clusters. At the same time, they are well separated. So we try to think a good clustering as the higher intra-cluster similarity. At the same time, low inter-cluster similarity. And the internal evaluation actually evaluate those characteristics. So they evaluate the quality of the partitions. The partition is done well based on these two criteria or not. That is called internal the evaluations. Or you can evaluate the clustering based on the result with a different clustering algorithms. Right, so the last component when you think about the clustering problem is how are we going to get the clusterings? So there are several algorithms available, depending on the characteristic attribute. So, connectivity-based clustering, centroid-based clustering, distribution-based clustering, and density-based clustering. And for this week, for this session, today's session, I will introduce the hierarchical clustering algorithm. And in the next session, I would like to introduce the k-means clustering algorithm. Okay, so one of the algorithms to compute the clustering is the hierarchical clustering. Hierarchical clustering is to find successive cluster using the previously established clusters. So with the hierarchical clustering method, we can go either bottom up or top down. So agglomerative method initially begin with each point as a cluster. So you can think about each point as individual clusters, and you successively combine two nearest cluster into one until you have the one big clusters. And the other way is the divisive method. Divisive method begin with the one big cluster and then successively split it. And today we will talk about the agglomerative method. Okay, so hierarchical agglomerative clustering is to repeatedly join the closest pair of the clusters until there is one cluster. So in that case, the dendrogram, which is the upside down tree, is used to represent such the hierarchical agglomerative clustering. So basically, it is built from the leaves. So leaves corresponds to each data point. And as already mentioned that, the HAC start with each data point as a single clusters, right? So the leaf part, this leaf part corresponds to each data point. And then you just successively combine two closest pair of the clusters. So for example, if you take a look at this two part, you may think about this 2 point. You took 2 point, you just combining as a one clusters, and then it can be represented in this way. You just build up, and then the height of this height represent the distance between two clusters, right? So this dendrogram actually show us how we combine the data point and clusters as we go along. And you can think about the strength of the hierarchical clustering as follows. So one is there is no assumptions on the number of clusters. So in that case, given the dendrogram, by cutting the dendrogram at the desired level, the connected component, each connected component actually forms a clusters. And the hierarchical clustering may correspond to some Minical taxonomy. So, in the biological science, they use this kind of the hierarchical clustering. So how I want to interpret the dendrogram? So each leaf, as already mentioned, that each leaf of the dendrogram is each data point. And then 2 data points that are most similar to each other in a certain metric. So you need to first specify the metric to calculate the distance between 2 data points and 2 clusters. Right? In case of for example, the Euclidean distance, are tied together and form a cluster. And in that case, when you draw the dendrogram, the height from the node to tie represent the similarity. Actually, it represents the distance between two clusters. And clusters are tied with the most similar data point or cluster in a certain metric, the linkage. And finally, all the samples are tied to the one root node. Eventually, you finish this iterative approach of the hierarchical agglomerative clustering algorithm because you have the one big clusters. All right, so from this tree, you can make the k clusters by cutting at the proper height. So there's no specific number of clusters. So if you cut here, each connected component, this part or this part can be your cluster. Or if you cut here, probably you have 1, 2, and 3 are 3 forms of clusters, and so on. So depending on how you cut the dendrogram at a desired level, you can come up with the number of clusters you want. Okay, so you may think that if the dendrogram is close to each other, you may think that they are very similar, but this is not the case. So in other words, through this example, what I try to say is the horizontal closeness does not necessarily mean the high similarity. If you take a look at the dendrogram, this cluster and then the cluster containing 9 only may close to each other. But if you take a look at the graph, if you take a look at the scatter plot, so these clusters and this cluster, indeed not similar, right? But they're close to in other words, 9 is as similar to the 2 as 9, 5, and 7, right? So when you need to be careful when you try to interpret the dendrogram, right? So horizontal closeness does not necessarily mean high similarity, right? Okay, so in today's session, we start with the discussion with what the unsupervised learning is compared to the supervised learning. And one of the unsupervised learning is the clustering problems. So we talk about what the clustering problem is. After that, we take a look at the 3 major concerns you need to consider the clustering problem. One is the proximity or decision in the measure. The second one is the how we're going to evaluate the clustering. And finally, we talk about the algorithms to compute the clustering. So after that, we take a look at one of the algorithms to compute the clustering, which is called hierarchical clustering, specifically hierarchical agglomerative clustering. All right, so in the next session, we're going to continue the discussion on the another algorithm called k-means clustering. Thank you.